Doc here with a question on frequency, but I'm going to call this frequency and period because I want to show you a marvelous trick to help you work your way out of something when you're not sure what to do with the numbers, whether to divide or to flip them and divide them the other way around, this kind of thing. And this question is a question that came up this week, and some students had some trouble with this. So I hope this will clarify for you when you get a question like this what to do. We want the frequency in hertz if 5 oscillations occur in 10 seconds, and we have 5 choices. The first step in the inquiry arc or the IARC model is to inquire. Make sure you have the right question. And I write down here in symbol form F equals question mark. Since we want it in hertz and per second is the standard, I just write down what's my frequency, F equals question mark. If you wanted it in per minute or something, then I would put in parentheses an alert for myself that it's not the standard one. This is standard hertz. Notice that I have given 5 oscillations in 10 seconds, and that's 5 times in 10 seconds. Notice that you could have oscillations here. You could have vibrations, rotations, revolutions, wiggles, jumps, swings. Whatever you have here, you can think they're cycles or things. It doesn't matter. I'm doing 5 in 10 seconds. And my definition for my frequency is the number of times I do something divided by the time interval for which these occur. So when I apply the formula here, I have 5 divided by 10, and that's 0.5 hertz, 1/2 hertz. I reflect on this to certify my answer. Remember, inquire, apply, reflect, and communicate. This is an important stage because many times students divide it the wrong way. Does our answer make sense? In other words, if 5 oscillations occur in 10 seconds, is it 0.5 hertz? Now I want to show you something here that's a really neat trick to help you keep things straight. Suppose you had 120 pounds and 5 feet, and I were to ask you which one is the weight. Well, you would say, well, 120 pounds, of course. If I asked you which one of those is the height, well, you'd say 5 feet. Because it's the word, say, or the abbreviation, the units we say in physics, what the measurement is made in, that gives away what it is. If that's a doctor's record, you're going to know there's a weight, the person, and the person's height. So here we have 5 and we have 10. Do we do 5 divided by 10 or 10 divided by 5? We're not sure. We're a little bit confused. Maybe we have a headache. We're taking the exam. What do we do? Well, if we include the letter, the unit, with the number, look what happens. The 10 has the seconds with it. So I have the seconds with the 10. Notice that here I'm in the denominator. I have 5 divided by something. And over here I'm in the numerator. So when I work this out, I have 0.5. That's the math with the numbers. But I have the seconds in the denominator. So I have 1 over the s. Over here, when I divide 5 into 10 to get 2, I have the seconds in the numerator. Now, if I were to ask you which of these is a time, you would say, well, this is a time. Which one of these is a frequency? Well, it would be the 1 over s. See, that's what gives it away. Just like pound gives away, this is a weight. Feet gives away if this is a length or a height. This gives away that that is a frequency. So your answer is going to be 0.5 hertz. You did it correctly. If you happen to have had 2 there and did this analysis, you would say, whoa, wait a minute, that's 2 seconds. Oh, that's the period. See, that's the flip of the frequency. If the question asks for the period, well, then that would be the correct answer. So if you put down 2, you're answering the question for the period, not the frequency. Remember, one is the flip of the other. This is 1/2, and if you flip 1/2, you get 2. So the answer is 0.5 hertz.